pipelines. And for that only that called as a jacket structure. So in that jacket structure, we need to design that number as per the code and the environmental conditions. So the major thing is the SAC will help the offshore engineering projects because it is easy to analyze the wave load and seismic loads in SACS. That's why that SAC is more important than other softwares like SAP Pro and other thing for offshore project.
Okay, so you are partially correct, but not fully.
Okay.
I will give you, I have few images over here. Let me know if this is clear. Okay, so this is how the oil will be present in the earth. So whether it's onshore or offshore, there will be a layer of soil, then there will be some rocks, and inside that it will be in 3 layers most of the time. So there will be gases on the top, then there will be oil, then there will be water. So we will try to extract this oil. So for trying to extract this oil, this is a jacket or a platform where there will be drilling and there will be a lot of other things involved, like they will be pumping water or they will be pumping meg and taking the oil. That is not a part of our concern. So our concern is, we know there is oil on the seabed and we know we need to extract it. So our idea was, earlier we will be having a jacket, but moreover that, if you look at here, so this is a typical oil subsystem level. So what happens is, we cannot provide jacket for each wells. So there will be n number of wells in a field. So if you look over here, this is a standard subsea system. So these items, the image may not be that clear. These items are called Xmas trees. So that will be on top of each well. So there will be Xmas trees over here. And from Xmas trees, we will be taking the oil. And oil will be collected to something called a manifold. So from manifold, it will be transported to nearby offshore production facility. It can be a jacket structure, it can be a tension leg platform, it can be FPSO. So are you clear with this part?
Yes, sir.
Okay, so now why other items are there? Because according to the height of the sea surface, sorry, depth of the sea. If you look over here, so you see, this is a fixed platform, what you call a jacket structure. So it will be it's fixed, and we cannot go to a higher depth with the jacket structure. Then we will be having compliant towers. So compliant towers are having a jacket type of structure, but it have some what we say, it has some ability to have little bit motion to resist the forces. Then there will be tension like platform. So if you look over here, these are buoyant structures which will be having a buoyancy compartments over there, and we will be connecting it to the seabed using tethers. It will be very tightened. So TLP has a lot of advantages, like even if we have a horizontal, it can bring back to the position. It's easy to install and easy to relocate as well. Then there is called a mini tension leg platform. Then there is called spar platform. Then there is something called floating production systems. So it won't be that it won't be in tension. It can move, but we will fix it with positioning systems. Then there will be floating production system. It will be ship-like structure, and we will be having all the production units on the top of this structure. So in the SACS, so now what you come, or what's your role coming is that you can contribute to design of jacket structures for sure. Then there is called topside module. So all jacket structures have 3 parts. So one is under the ground where the pile everything will be there. Then there will be a jacket structure, and then there will be a topside module. In topside module, there will be having every all facilities like accommodation, processing, storage. Everything will be on the top side. So in the SACS, you can model the structures of these things and do the analysis. But for FPSOs also, there are topside modules. So for all these structures also, there are topside modules. And in offshore industry, they usually use SACS to design these topside modules as well. So SACS doesn't just confine itself to for the jacket structure. We can use it for different aspects as well. And why SACS? So SACS have a very unique property. Do any of you guys know ANSYS? Uh, can I get a
No
No,
idea.
sir. No.
okay? So something with ANSYS is that you need to give all the properties. It's like lot of time to analyze the structure and to give the results. But SACS uses a beam element software most of the time. So we will be simplifying the model to beam element software, and it will give very quick results. Sometimes it may not even take 1 minute to give your results. So due to this advantage, we can do lot of iterations. In a single day, you can do lot of iterations. You can change the model. You can change it to see how it behaves. So computation time is very minimal in SACS. That's why people used to prefer SACS for analysis. Even in my company, so how we approach a problem is that if we get a problem, first we will look at the easiest part. What is the easiest part? Do a hand check. So do the calculation with hands, and if you are able to solve with hands, we will tell that okay, this design is good enough. Now, if we are not able to solve it with the hand because the structure may be complex, then what we will do? We will go to SACS. We will go to SACS, model the structure, give the boundary condition, give the loading, and we will get the results. And if it's not passing out, we will change few section properties or change the design. We will get the results and give the feedback. Now, sometimes SACs also have a problem. Like at the joints, it may not be coming proper because I told you, no, we have a approximation in SACs. So at that time, earlier we used to do it in ANSYS for that single part. But in now in SACS, we can model the joints as well separately. We will go through everything in depth. I'm just giving an introduction. Okay. If you are not clear about anything, let me know. And so this is the main thing about the types of offshore structures. So this is clear, right? Now coming to something called okay. Before we going to these things, um, now what are the loads that can act on a structure? Anyone?
Dead loads, imposed loads, wind loads,
Yeah. So we will
seismic loads.
yeah. So we will classify it to few things. So something there are static loads. Dead loads. Dead load is a self weight plus some equipment over there. Then live load. Live load means the weight of the people and all sort of things. Then there will be um, yeah. So then there will be environmental loads will be there. Environmental loads are most of the time it is dynamic because waves are dynamic, wind is dynamic, current is dynamic. So we need to encounter all these loads. So we have two types of analysis mainly, static and dynamic. For the static loads, we will do the static analysis. And for the dynamic loads, we will do the dynamic analysis. So if you come over here, let me, okay. Now, now coming to the structure. I told you here we have lot of subsystems. So your work will not just confine to design of a jacket structure or tension leg platform. You can even model a subsea structure also in a SACS. So I will give you some examples. 1 minute. Okay. I'm trying to bring a node uh, classroom board experience. I'm not sure. Let me give it a try. If it doesn't work, we will go with slides from next class. Okay. Um, okay. Now, uh, while coming to all the subsea items, we have few stages because we have a structure. So let's say we have a structure. So let's say XYZ structure. So this is fabricated in somewhere in the fabrication yard. So it may be closer to the port side. So we have few things. So this is a fabrication yard. So this is a fabrication yard. This is the location where your structure is there. Location, and this is the sea. So there will be port. So you need to take this structure and we need to bring it here and install it. So what all stages will be involved? So you have a structure here. So you need to bring it to the port side, right? So for that, you need to have an idea about road transportation. Road transportation. So now you coming to the port side, you will be having vessels over here. Okay, ships over here. And ships are of different types. There are installation vessels, there are heavy lift vessels, and there are installation support vessels. So now then there are barges as well. So now let's say we have a small structure. Now we need to lift this one and keep it over here. So this is called lifting analysis. Where the lift is happening on the port, right? And from once it is lifted to the vessel, we will transport it to the site. So that is called transportation analysis. Transportation analysis. So once we bring it over here, we need to, so our vessel is now here and we need to install it. So again, there is a installation, there is a lifting, and where the lifting is happening in offshore, right? So when you install over here, let's say this is a vertical, this is seabed and this is sea level. So this is the ground and this is the sea surface. So now let's say there is a crane from a vessel and you are installing. When the structure is here, it is called lift in air. Once structure is on the sea level, it is called splash zone. So here lot of forces will be there. So the dynamic amplification factor will be high. And then we are bringing it down and installing it over here. So this is called installation. Sometimes we may need to recover the structure. So while recovering, it is called a recovery analysis. Now let's say the structure is installed at the seabed. Structure is installed seabed. So it will be functioning in the seabed, and there will be lot of forces acting on it. So at that time we will call in place analysis. Are you guys clear?
Sir, can you spell impulse?
Okay.
IMC?
Okay. I will type it over here. Okay. First,
Lifting analysis.
so lift. So this 1 minute. First is lift. Where it's happening? It's in onshore lift. Okay. Before that, we have one step. Road transportation. Road transportation. Then lift on onshore. Then sea transportation. Then what we have? Installation. In installation, what we have? So installation, we have few things. Lift in air, lift through splash zone, then lift through water column. So when we lift it through the sea, we call it lift through water column. And now once it is on the seabed, it will be having some operation there. We call it in place analysis. And if you want to take the structure out of the sea after its lifetime, we will call it recovery. So are you guys clear with these steps?
Sir, can you please explain lift through splash zone alone?
Okay. Lift through splash zone, I will explain. So now I will try to use the mouse now. Where is it? Okay. Okay. So let's say this is our seabed. Okay. This is our seabed. And this is our sea surface. And this is our vessel. Now we have a crane over here. So what crane will do? Crane will be lowering the structure. So crane will take the structure from the vessel deck or from a barge, and it will lower. So it have ropes so that it will enable it to lower. So now the structure is in air. Okay. Structure is in air. So only external force acting on it is the wind, and due to the motion of the ship. So when the ship also moves, it will be having certain type of motion, right? So those are the motions on the structure. Now we are lowering it. We are lowering it, and once it touches this sea surface, sea is not stable. It will be having waves and all. And this region, when it crosses, we call it, it's a splash zone. So water will hit on the structure. The structure will have more forces because the waves are hitting, the wind is there, and there will be slamming as well. Slamming is the water will hit on the structure from the bottom. So this will create instability to the crane. So it's very critical. It's very critical. So this is called splash zone. So we will call this operation splash zone crossing. Is it clear, Ganesh?
Yes, sir, clear. Thanks.
Maybe let me try to get some YouTube video. Maybe it will be more clear.
Okay.
Subsea installation. Subsequently, let me check this one. It's not subsea manifold installation. So this is road transportation.
Okay.
They are bringing it through the road. So there will be offshore cranes. Now they place it on the vessel. Now they are sea fastening it. I will tell you what is sea fastening.
Okay.
So now this is sea transportation. This one is loan installing TDX. I think this is a simulation. Okay. It is very slow. Okay. So you look over. So now they are going to. So the operation what happened earlier, that is the structure was on the deck and the crane took it from the deck and it rotated to the other side, right? So that operation is called slewing operation, slew, SLEW. And now it is in air. This is splash zone. Clear?
Okay, sir.
Ah. And this is how the installation goes. So once the structure reaches the seabed, there will be ROVs. ROVs will drag the structure to the required position, and there will be sensors on there. It will be showing that survey sensors like LBLs and all. It will show which location it's exactly be installed, and they will install it over there. So that is the installation process. Now, what you want to take care of is, now what we will focus is, we will not design the jacket now. So we will design the few basic structures. We will do the basic transportation analysis. We will do the basic installation analysis, and we will do the basic recovery analysis to understand the things. Now, I think you have a certain picture of things, right? Are you guys clear till this? portion?
Yes, sir.
Okay, so now if we go over here, you need to know few more things. So have you heard about port, starboard somewhere?
No, sir.
Okay, so when we tell about a ship, so ship always have two sides in length, right? So one is port side and one is starboard side. How to identify it? Now let's say this is a ship. So the ship is like this. The front side we call it bow, and back side we call it aft or stern. So this is stern. Oh, this is not working. So this is stern or aft, and here it is bow or forward side. Now if the bow is here, the port side will, if you are looking to the ship from the front, so let's say ship is looking like this, you are looking towards the ship from the front side, so always this side will be port and this side will be starboard. So you are looking from here, right side will be port. This is port side and this is starboard side. We will call it in short form STB. Okay, so you should be familiar with these terms. Clear? Any doubt? Ganesh, Arun, Sandhya?
No, sir.
No,
Okay,
sir. Fine, sir.
okay. Now, have you heard about degree of freedoms? If you don't heard also, it's fine.
Yes, sir. Little bit we know degree of freedom.
Okay, so degree of freedom is like in which direction it is free to translate or rotate. So if you look at ships, we have 6 degree of freedoms. 3 is translational and 3 is rotational. Now, when we draw a ship, always from the back side, that aft side, to the forward side is x-axis. Okay, this is x-axis, and vertically upward is z-axis, and towards port side is y-axis. But here there is some deviations. In some regions, they will take towards starboard side also y-axis, but it's fine. But be careful where your coordinates are. Now, if the ship moves in surge means it is going front and back. The ship is moving front and back. That is called surge motion. Okay. Now, if it moves along y, that means the ship moves from port side, starboard side, port side, starboard side. That movement is called sway. And this is very important. Heave. That means if you just picturize a ship stands on the sea, it goes up and down, right? Have you been to any boat sometime? Hello?
Yeah, yes, sir.
Okay, so when you are in a boat, the boat always in a motion, right? It's not like our when we go in a car or a bus, but it's always in motion. So when the boat goes up and down, it is called heave. Okay, surge is to and fro, front and back, sideways it's sway, and top it is heave. Clear? Okay. Now a heave is very important because heave, when it goes up and down, the weight we feel will change. Sometimes we will feel like, oh, our weight is increasing. Sometimes we will feel like, oh, we are like floating. So he will definitely matter more during the transportation. Now another thing is rolling. Rolling is ship will roll along the axis of x. So that will, if you are sitting on a boat, it will first rotate towards your right, then rotate towards your left. So that is called rolling motion. Is it clear?
Yes, sir.
Yeah, okay. Now let's assume the ship, the front is going down and aft is going back up. Then at the second thing, front is going up and aft is going down. So that is called um, pitch motion. So this is roll, this is pitch, and the yaw motion is it is just rotating along the z axis. Let me see whether again videos are there. Search sway yaw. The keyboard have some problem. This will be better if you think with the plane. So 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 this is the roll motion. So it is going sideways, and this is yaw motion. It's clear?
Sir. Yes, sir.
Okay. So these why 6 DOFs are important, because when we do the transportation analysis, all these motions will be coming into effect, and you should secure your cargo to save your cargo from losing out due to these motions. So to secure the cargo, what we will do, we will sea fasten it. So when you are transporting goods on the truck, you will secure the cargo, right? We will just tie in and all. We should do, right? If you don't tie in, what will happen? The cargo will move across the truck, right?
Sir.
Yeah. So in the ships also it's the same, because we are transporting heavy objects, and at the sea the motions will be high. So we need to secure it. So the securing of cargo is called sea fastening. Are you clear with the term sea fastening?
Yes. Yes, sir. Yes.
Okay, I think
Yes.
we have covered almost the basics to start it. Are you guys clear with these items? If you are clear, then we can directly go to SACS and do something. That will be more interesting.
Okay, sir. We can-
Okay,
Yes.
and what I will do right now is I have few NPTEL courses. I have take a list of few NPTEL courses. So this one is the course. 1 minute. Okay. So this course is by Professor Sundar. He was my professor in IIT Madras. He's a very good professor. So when you get the time, you go through this. He will be explaining how a wave is happening, and what are the types of waves, and what happens when the waves interact with structures. So you should go through this course. Let me see how much is the timing syllabus. It is total 46 hours, but what I would suggest is go to the basic fluid mechanics, go to the classification of waves, then just quickly understand what is this one. Maybe you can do a Wikipedia search and understand these things. Spectrum you don't want to worry about right now. Currents you should go through. What is a current, how it is behavior, then the wave forces. This is little bit important. Okay, so you go through these to get a primary understanding of this. We may need it when we start the jacket analysis. It will be after 2-3 weeks, so you have time. You should go through this. Clear, right?
sir.
Yes,
Okay.
yes.
And the second one, this is design of offshore structures. So design of offshore structures, it's a very lengthy course from Nalla Arasu. He was advisor for L&T. He's also a very good professor. So Jacob Rigg, you don't want to. So just go through the first part, loads on structures. That may be enough at this moment. Okay. So you go through loads on structures and concept of fixed platform jacket and deck. These two is main important. If you have time, go through next two as well, steel tubular member design and tubular member design. Okay. And for the third one, this is a big course. So this one is foundation of offshore structures. So here it will be coming into handy when we do the pile structure interaction and all. So this is a very detailed course, and even that he provided textbook. So try to go through some lessons in Q. We may need it towards the last part of our training session for the pile soil interaction. So this is also very important. If you click on this link, this is a notebook for that course. It's very heavy. It is almost how many pages? 978 pages, 450 something GB. So I would suggest you guys go through this course. Can I post in the chat?
Okay, sir.
Okay. So I have posted this one. You go through these courses and come back to me. Okay. So I think you have a basic introduction to things happening in offshore. Do I want to tell or explain again any of the topics, or can we go to SACS?
We can go to software, sir.
Okay. I think that will be better because our courses is about SACS and we need to spend more time.
Sir, if you can zoom that ship, that plan, no, just for me to draw. I
Oh,
missed
this
it.
one.
Bow stern.
Maybe I can share this whiteboard with you. You guys have.
No,
Let
I
me
have
go.
taken down. Oh, no problem. I
Okay,
got it.
you got it.
BOW and FOW.
Okay, maybe I can share this whiteboard with you. I just use this whiteboard to whiteboard to just scribble down a lot of things.
Okay.
Okay, so you can go through this whiteboard. Okay, now we will go to SACS, our important one. Okay, I hope you all installed SACS, right? Okay, which version you guys have? Is it SACS 2024?
It is B15.
V15. V15 is also good. It's fine. Okay, now we are starting it. So once we start the SACS module, it will connect to the Bentley server. Okay, so you will have all these options coming. So this is basic one, SACS offshore structure. So here you can do almost everything except for topside loading and global loading. So if you want topside loading, you should go to offshore structure advanced. If you want to give global loading like environmental loads, like wave loads, all sort of thing, you should use offshore structure ultimate. Now now we can start with SACS offshore structure. Okay, I'm just starting it. Okay, so this will be the interface you will be getting. So here you will be having the files, and here you will be giving the folder which you need to work on. And here this is the basic settings. Now you don't want to explore anything right now. For that, maybe when you have time later, you can go through this. to see, set the settings for this, set the project for, then if we have any interactive programs, we are not doing any interactive programs here with Hull modeler or anything. So you don't want that right now. So these are utilities, these are supports. So you don't want to get on anything right now here. Just stick on to the home page, and here is the program launcher interface. And here is the analysis information interface where it will show the status of the analysis. And if there is some comments, it will be over here. If you want to see the output files, it will be over here. And this is analysis generator. So we will come to this part. And in SACS, first, do you know the full form of SACS? Anyone?
No, sir.
Did you search it even anywhere?
Yes, sir. Yes, sir. Structural analysis computing system.
Yeah. So it's a very simple abbreviation. Okay. Now here we can create the model two types, two ways. Either we can use a 3D modeler, it will have a 3D interface, or you can have a data file, it will be text based. Earlier people used to do it in data file entirely, but as a beginner the modeler will be best for you. So you can select the modeler. So modeler will ask for three options: modify existing model, create a new model, open the last model. Now we will go to create a new model. So once you click on create a new model, another window will pop out. So the modeler is called proceed. So it will ask, do we want to start a blank model, or do we want to use structure wizard? So if we use the structure wizard, we can model the jacket structures, everything using structure wizard. Okay. And which units you are using? Is it the English one? Because have you worked with American companies or American clients?
Yes, sir. Actually, we are working in AAC standard only, sir.
You know, right? They don't use our metric system at all. They will be always using feet, LBs, KSIs, PSI. So we always stick on to the metric for now. But if you are working with American clients, select English. Okay. But
Okay.
for the rest of the world, metric. So now I am going for the metric. It's only about defining the unit. You can change at any point of time. Now we will
Okay.
go
Okay,
with
sir.
start blank model. Okay.
Okay.
Now we are starting it. So this is the basic design window. Can you guys come to this point in your system? You guys can.
Yes, sir. 1 minute, sir.
One
Yeah.
minute.
I'm closing this down. I'm still in the files. Come to this, the first one. You open SACS, select the first offshore structure, and come to the first window.
Okay, sir.
Yes,
Okay.
sir.
Now, before starting our modeler, we will set few things over here. So I told you this is the files folder, right? Now you create a folder somewhere in your computer. So yeah, that will be our working folders. Now I created one folder. You create somewhere some folder.
Okay, sir.
So I'm copying this one. I'm copying the address and coming over here and pasting it. And click on the go. So now what happened is that the folder which we created had become the working folder.
Okay, sir.
Okay, you all of you came till this point.
Sir.
Okay, now click on the modeler, create new model. Start blank model, metric, and click OK. Okay, so you all raise this. Ganesh, can you mute?
Okay, sir.
Okay, so you all raise this window. Now let us explore. Okay, if you go to the file, here we can create a new one, open, save as, print plot, import and export is there. You can import and export the models, and structure definition. And if you come to settings, so you all have white background in the SACS mod window.
Black, sir.
You have black. Okay, so I'm personally with white. I will tell you why I use white. Because if it's fully black, if you take the screenshots and put in the design reports, it may not look good. So I used to change this background settings to white. It's a personal preference only. I will show you how to do it. Okay. If you come to display, you click on the settings, come to display. Reached? Do you see this top background, bottom background, joints and labels?
Yes, sir.
Okay. So if you click on this, you can select the which color you want. So one thing to remember is you can keep it black, no problem. One thing to remember is if you are putting background as white, then the joints and labels should be black. I think for now you guys, these two are black and these two are white, right?
Yes, sir. Yes.
Okay, you can keep it or you can change it. It's personal preference. Maybe leave it there for now. We can change it later. So if you're changing it, click on this. You can change the color for both and just click OK. It will set. Okay, so that's not a big deal. And one more thing. If you want to set the units, you can come over here and set the preferred units you need to work on. Sometimes you guys prefer to work in meters. You can change the default units and put everything to meters. But in SACS default, some things are given in centimeter. Some things are defaultly given in meter. We can change at any point of time in SACS. There is not a problem. So you can change it. You have option to change it over here. Now cancel. So now if you come to the second part, so this is our menus. So these are called ribbons, and these are quick access toolbars, and this is a short toolbox. So here we have home. Home will have everything with respect to display. I will explain each and everything what is display meaning. So these are regarding the views. Um, uh, these are, you can give joins with this one, you can create member with this one, you can create plates with this one, you can create member groups with this one. You will go to each and everything. So if you want everything specifically for display, there are a lot of options. If you want to activate it, go to display. Then this is regarding the joins, this is regarding the members, plates, shell, property, loads, how to give the loads like join load, member load, self weight, another load properties, how to combine loads. Here you can define normal weights. Here we can define the environmental loads. Then there are few other optional things with respect to hydrostatic collapse, water depth, all sort of things. These are miscellaneous for model checks and all. These are, if you want to add more window, you can add it over here. This is the help button. Now we will have you used StatPro? You three are from civil, right?
Yes,
Yes,
yes.
sir.
Okay, so if you have used StatPro, this is almost similar to StatPro. Okay, so it will be very fast for you to understand. So in StatPro, how we will be how we'll be designing it. First, we will be designing the joins. Then we will be creating member properties, and then we are assigning members. Then we are assigning boundary conditions. Then we are assigning loads and do the analysis, right?
Yes, sir.
Yeah, this is almost similar. Okay, so I will show you how to start. So first, everything will start with joins. Okay, so joins, you can start it like this. So this is like absolute join. So when we come to absolute join, we need to define the actual coordinate of the joint. Okay, so now we are creating an origin joint. So if you look over here, there is a join name. It's 4 digits. So you can give any numbering. Maybe you can mix alphanumeric as well. So here it's 000. You can put A001 or A1, A1 also, A1, anything. It can go till 4. It doesn't mean that you need to always give 4 digits. Maybe you can give 1 digit as well. You can give numbers, you can give alphabets. And this is very important because when we do the design for normal structures, no, we need to give a lot of naming sequence. So this will help you out. So now, why this? What this box is all about? So let's say I am creating few joints with the name A001. So I am putting A001. Now, if I want to create another joint, I need to come and change it over here. So instead of that, if I use this option, automatically it will take the next number as A002. It will come handy when you are creating n number of joins. At the moment, just understand that there is some option like that. Now the coordinate, it's very important. You should be very careful before going it. I told you, we set this as meter. It's a default. Now, if you are designing small structures, the coordinates you get maybe in mm. It can be in centimeters. At that time, you don't do the painful thing of mentally converting it to meter or centimeter. You come here, select whichever this one you want, and give the coordinates. And here, one advantage what we have is that without changing the overall unit system, you can select feet or inches even here, because sometimes we are doing it for a European client and the structure was designed in America. So you will get that values in feet or inches, but you need to do all analysis in metric. So at that time, it will, for modeling, it will be easy if you toggle it over here with the units. Now I am selecting for M. I am trying to create a centroid. So if you click on tab, it will go to the next field. Tab key on your keyboard, no? So it will avoid you to manually hovering the cursor over the fields. Now come to the fixity. Fixity is very important because fixity defines the boundary condition. In StatPro, how you will give a pinned connection? Anyone? Sandhya, Arun, Ganesh.
So just adding
Supports.
Okay.
Support option.
Yeah. So here I will tell you how we are doing it. So here we can define the fixity. The default value is 0, 0, 0, 0. So now what is this indicate? Okay. So we have 6 digits. 1, 2, 3, 4, 5, 6. Okay. So this one is fx. So this is fy. Oh, sorry. Fy, and this is fz. This is mx, my, mz. Now tell me, what is fx, fy, fz?
Translation in X direction.
Yeah. So this is translation. This is rotation. And what will happen if I give 1, 1, 1, 1, 1, 1? So remember that for joint fixity, 1 means we are constraining. It is not free to rotate. And 0 means it is free to rotate. It is free to rotate. So now if it's 111, 111, what will happen?
Fixed.
It's a fixed support, right? 1 minute. So it's a fixed support. For a pin 1, it will be 1, 1, 1, 0, 0, 0. Right? So for a pin connection, it will be 1, 1, 1, 0, 0, 0. Now, what will happen if I give a joint 1, 1, 0, 1, 1, 1? What will happen if I give this type of fixity? So there is a joint.
Roller. Roller type support.
See, third one is 0. Okay.
Okay. Roller means translation only in one direction. Okay. This is not
So here, what is FC?
fixed but
Fixed, but it can move in Z axis, right?
yes.
It is
yes,
free. It is free to move in Z axis. Now,
yes,
if I give this one 1, 0, 0, 0, that means it is free to rotate. It is free to move in Z axis, but it will not move in X and Y. Right?
yes, sir.
Okay.
Yes,
So these are regarding the fixities. Okay. Now for our case, I am, if I give nothing, it will be like free. I am giving free, like 0000000. Now what will happen? A joint is created. You see this one? A cross. If it's a X, that means that is a free joint. And
Sir, one doubt, sir.
yes, ask me.
There are 6 options in the fixed. What will happen when we click on fixed and that option, sir? What value it will take?
I will show you.
Okay, sir.
Okay. So now coming to the joint, we created a joint. Now if we come to the display, what will happen is, if you click on this one, it will show the join number. Clear? Display joined. If you click on this one, it will be showing the join number. And if I click on this one, join fixity, if some fixity is there, it will show the fixity. Now it is free, it's not showing. Now I told you, if I click on this box, it will automatically a number. No, if you see, you change the number, right? A001 to A002, and there is something called here status bar. So when I clicked on the apply, it shows status that joint A001 has been added. Now I am creating another joint. It is at 10 meters from X, from this joint in X direction, and 10 meter, and I am giving a fixed support. So fixed support. So if I create this one, it will create another joint with fixed support. Fixed means 111 pinned means 11100. It's almost same. So you create pin or this one, it's same. Okay, but I would suggest you go with this one. If you click Control Z, that will be undo. Let me change this. So this is, so since we click on join fixity, since this joint have a fixity, we show the fixity over here. Now look at these joints. Do you find something in the shape of it? This is a X and this is a triangle, right?
Triangle, small triangle.
So this is small triangle. So always a triangular joint means it has some fixities. It will be easy for us to identify. We gave some axillary fixity to some point. Okay, if it is a X, that means it doesn't have any fixity. That joint is free to move. Clear, right?
Yes, sir.
Okay. So that is creating the joint. Now we need to create a member. So for creating a member, what we need to have?
Joins.
No, we have joints. Okay, we have joints. So now
That
consider
number options.
yeah, we need to have member. So if I go over here and if I connect it to create a member, but it doesn't have any properties, right?
Yes, sir.
So we need to assign some properties. For that, we need to define properties. So what are properties we need to define? Two types. One is material, one is section. Right?
Yes.
So to define those properties, you come over here to property tab. And here we have two. It's a member group and a section group. So first we should define the sections. Then we should define the member. Clear? If you come to the member section, so this is called a section manager. So let's take through this. This labeling option, this is to label each section. It can go up to 7 digits. 1, 2, 3, 4, 5, 6, 7. You can go up to 7 digits. So you can name your section such that it can be easily identifiable. That is a good practices. Okay. Don't just give B1, B2, B3. It will be very tough for you to understand which section was this rather than just looking at the name. If you just give some generic B1, B2, B3, every time you need to go to section properties to understand what type of section is that. So when you are dealing with one structure, one section or two type of sections, it's fine. It's easy. You don't want to worry anything about. But if you want to deal with the n number of sections, let's say you are designing a big structure and you have, let's say 10 to 12 sections, then at the time it should be better to name it properly with section numbers. Okay, so here are few examples. So if you look at section manager, here we can add a section. So if you add a section, it's a user defined one. If it's a tubular, you can give outer diameter, wall thickness. Let's explore everything. Now this is a white flange. So let's say the client gave you the catalog of the white flange. You can take that catalog and upload it here if there is not in section library. Then there's a compact white flange, box section, prismatic. Prismatic is just a bar, with a certain cross section in Z and Y. Y is the length of the bar. Then cone type, channel, T, angle, concentric tubular, plate girders, stiffened cylinders, stiffened boxes. So here you can define the stiffness. Dented tubular, launch runner, jack-up leg, double angles, rectangular tube, double web plate girder, unsymmetric girder. Sometimes you need to make unsymmetric girders as well. This will be very handy. Bulb stiffness and this fleshy launch runner. So you have a lot of sections available in here. You just want to update these properties. Now if you come into the section library, there will be some section libraries. So if you want to select a white flange from here and apply filter, so you will be having different types. So look for what are the requirements from the client and select which one you need. Now I am selecting a W10X. And if you select directly like this, it may be hard for me to get it. So now just I put B something. I am putting a new word. And if I click on copy, what will happen is B will have all the properties of that double. So in some cases, you need to you can copy the section types and make minor modifications. So this copy option will be helpful for you. Okay, now we have this one as defined section. Close it. Now coming to the member group. Here we can define the name of a member. So I think here it is 4 digits only. No, it's only 3 digits. You can go up to 3. So let's put to B01. And you are creating a member group. Okay, come over here. So we already said it's a general one. Section label. So here also we can define if something is there. If there is a plate girder, we can define like that. But you go stick general because we already defined a beam. If you have a tubular, we can define directly outside diameter, wall thickness. but I now selecting general. Click on this section. Okay, so this section label is assigned. Now this is the E value, G value, Fy. Here you can change whether it's a 355 steel, you can change it to 335.5. Density remains same. Segment length you don't want to define, because the rest of the things we will keep it same. And here is the color. Color is also important. So what will happen if you use same color? It will be very difficult for you to identify or distinguish items, right? So I will always prefer to select different color for different beams. So how to select color? Come over here. Here are some user defined basic colors which are given by the SACS. You can define a color and add. Now if you come to miscellaneous, now just keep it in mind, we are not going to use it. There is something called gap element. Okay, so what is gap element means? So how our structure behaves. Let's say, okay, it's some sort of wall. This is a beam. Okay, now let's say this is standard beam. I have welded over here. I have welded over here. So if I apply a load here and a load here, what will happen? This will be in compression, right? Hello?
Yes.
Sir.
Okay,
Yes,
so
sir, yes, sir.
yeah, if I give the load in opposite direction, it will be in tension. This will be in
Yes.
tension.
Yes,
So
sir.
that we call a standard member. Okay, most of our beams are standard. We don't care much about it. Now the case of a sling. Instead of a steel beam, I replace it with a sling or a rope. What will happen in tension? Rope will be in tension, right?
Yes, sir.
But what will happen if I compress it? Will it take any load? No, right?
Which
If it,
material, sir?
yeah, it will not take any load. It will just deform, and it will just move it. It will not take any load. So
Yeah, other than steel, right, sir? Which material, sir?
no, instead of steel, I replace it with a rope. Now,
Rope.
now,
Rope. Okay, okay, fine.
now think the beam is not there at all. Beam is not there at all. I
Okay.
have just a rope. So if I give tension load, the rope will be in tension.
Tensions.
But if I give a compressive load, what will happen? The rope will just deform and it will not take any load.
It's deformed like a bending.
Yeah.
Yes, yes.
So when we are designing something like this for lifting and all, we will define it as a tension only member. You got the concept of tension only member, right?
Yes.
That is called a tension only member. It will take only tension. If compression comes, that structure will not take any load. So in some cases, we need to define like that. Then in some cases, we need to define compression only member. I will tell you an example about a compression only member. Okay, now just consider I have a box over here. Okay, and this is a wall. This is some sort of a wall. And I am pushing this box from this side. So I am pushing this box from this side. So what will happen? Till the box touch this wall, or let's say box is touching the wall. when the box is touching the wall, it will resist the motion, right? A compression load will be acting and it will resist the motion. Okay, it will act like a stopper. Now, let's assume I'm applying the load in another direction on this box. What will happen? The box will move, right?
Yes.
The wall will not play any role at all.
Yes. Yes.
Okay, so when we want to define some contacts like this, we will give it as compression only member. We will define the contact as compression only member. Did you get the concept? Tension only member and compression only member.
Yes.
Yes, sir. Yes, sir.
Okay, so now coming over here, if you want to define what, so when we define anything as a tension only or a compression only member, we will call it as a gap element. Okay, just remember the name gap element. So here I can define whether it's tension only, compression only, whether it's a no load, it will take no load, or it's just a friction. I can define it as gap element. But for now, we are not using gap elements. We are using a standard member. Okay. So we defined a member. So now I need to assign this member property. So I have two options. Either come to member, go to member property, click on this member, and here I can bring the group label. So if I apply, the member came, right?
Yes.
So, so how to activate the 3D? This is the button to activate the 3D to wire free. Okay, now here you can zoom it. You come to cross section. Now, how the beam is oriented? Beam is oriented in Z axis, right? The
Yes, sir.
joint we defined always coming to the geometric center. Okay, so what happens if the cross section is unsymmetric? Take the case of a L shape or a T shape. The center will align to the cross-sectional centroid, right? Is it clear?
Yes, sir.
Okay. So now let's say, oh shit. Now let's say we have a L-shaped structure. So centroid will be somewhere here, right?
Yes.
So when you take the joint, when you define a joint, the centroid will assign it over here. Now I will show you some tricks to modify it. Now let's say I need to have the beam in another way. I want the flange to come this side. Now if you look, flange is in Y axis. I need flange to be in Z axis. I need to rotate the beam. So this is the option to rotate the beam. If I rotate by 90 degree, oh sorry, if I rotate by 90 degree, it will rotate like this. So this is a very helpful tool. You can rotate to any degrees. You can rotate to any degrees. 45. So now I will bring it to 0. So here also, always remember, once you define the section member, here also you need to activate whether it should be a tension or compression. Okay, you should activate it here as well. Now, if you look at, if you now you want to know how the member is aligned. For that, you need to activate a thing called no, not this one. 1 minute. Where is it? Display. I'm missing one option. Let me see. This is member and release. Leave it. We don't want member and releases. Local coordinate axis. So always check this local coordinate axis. So this indicate our member went from here to here. So that is the orientation of the member. And we will define all the internal forces according to the member end. Now, important thing, if you come to the member, come over here, you see something called A release, B release. So this one, have you heard that member releases in StatPro?
No, sir.
Okay, so why we need member releases is sometimes we need to design some member. You know about this moment connection, shear connection.
Yes, sir.
So what happens to the shear connection? It will not transfer the moments, right?
Yes, sir.
So here, if you want to release, you can do this like that. If you want to release all the moments coming to a join, let's say the B. If you click on B, it will show the B 0, 0, 1, 1. What will happen is this is exactly opposite to our joint fixity. In joint fixity, if you give 1, what will do? It will constrain, right? And if you give 0, it will release. But for member releases, 0 means it will transfer the load. 1 means it will not transfer the load. Okay. Confusing, right? Arun Sandhya, is it confusing or are you just
Sir,
clear with that?
you can type in the tensor so that we can understand.
Okay, so the thing is,
One means it will not transfer the load.
no, for this one, joint fixity,